And now we are in homework for problem 2. In this problem, we know that the random variable x is uniform in the interval -1 and +1. So from this condition, we can infer that the distribution function of x in this interval should be this. Should be like this, because the value is from 0 to 1, and the interval of x is -1 and 1, so it should be 1 of second x plus 1 of second. So that's the distribution function of x in this interval. So and also when x is no more than -1, the value is 0, and otherwise it should be 1. So that's the distribution function of x from this condition. And also the question needs us to find gx such that if y equals to gx, then the density function of y should be this. It's the density function of y. So now we need to find gx, and we know that y equals to gx. So we need to find this from the density function of y. Because the density function of y is equals to this, so we can transfer this into the distribution function of y. We just use integral transmission, and we got this. And also because y is actually dependent with x, so when x is we know that for x in this interval that x is larger than -1 and less than 1, then the distribution function of x is this. It's kind of random variable function. So for distribution function of y, the random variable function should be like this. So this function is in this interval. So and also they are dependent with each other. So therefore this 1 minus the power of -y of e equals to this. So and therefore y equals to this, and this is gx. So now we have gx in this interval x no less than -1 and no more than 1. And also for x no more than -1, gx should be 0. And also for x no less than 1, gx should be from this equation we know that gx should be positive infinity. So so this is the result that the result should be like this. Y equals to gx equals to 0 when x is smaller and less than -1, and equals to this x in this interval, and also 1 otherwise. So that's the result of the question 2.